Hey, what's up guys? Today we're learning how to put a camera or any other object on a rail so it follows you around in a level just like this. Alright, let's get started. Hey, what's up guys? In this tutorial we'll learn how to put a camera or any other object on a rail so we can move with our character in a level and it just follows it on a certain path. Okay, so without further ado, let's get started. First thing we will need to do is we will need to create a rail script. So this is going to store the information of our rail, and we are going to open it. In there we will be declaring some fields, so a private vector3 nodes, and we're not going to assign it just yet. We want to wait until we know how many nodes we have. So private int node count, and this is going to be determined at the start function. So let's do that right now. Actually, let's go ahead and create a private void start function. In there we'll say node count is equal to transform dot get child count, which is a function that simply calculate how much or how many childs you have in your transform, and we're going to say nodes is going to equal a new vector3 of the value node count. So there's going to be as much vector3 as there is nodes in there, or children's. And then we're actually going to go ahead and assign those. So for int I is equal to 0, as long as it is smaller than the node count, we are going to say I++. And in there, of course, nodes at the index I is going to equal transform dot get child index I, oh, it's a bit messed up, index I dot position, because we're getting a transform out of that. So close this off, and then so just for the sake of looking at this visually, we're going to go ahead and create a private void update, and this is not necessary. This is only to look at our rail system. So we're going to start by saying if node count is bigger than 1, because if we only have one single position, we don't have any segments, so we don't have a rail. We need to start and finish position. So if we only have one, we're simply going to return. But if we have more than one, we're going to say for int I is equal to 0 again, as long as I is smaller than node count minus 1, and you'll see why in a second. We're going to say debug draw line, and we're going to draw the nodes I can't write, nodes at the index I, and also node at the index I plus 1. So the plus 1 here is why we need to do a minus 1 here. Okay, and we can also give it a color, so for the sake of this tutorial I'll give it a green. Now let's go ahead and create ourselves a little rail system. So new game object that I'm gonna move at the origin. I'm gonna call this one rail, and just for seeing it, I'll simply put a tag on it. So here we go. And now the way our rail system works is we are going to need children's in there, so we're going to need some waypoints. So let's go ahead and create spheres. Just for the sake of seeing it again, I'm going to remove the collider. And this could be empty game object, this could be pretty much anything, as long as it has a transform component. So this is going to be a node, and I'm going to drag and drop this on the rail, so it is the children of rail. And now we can go ahead and create ourselves a little network. So I'll go ahead and cut this, copy it again and again and again, and I'll have one over here. Okay, so now let's take our rail script, drag and drop this on top of our parent object, hit play, and as you can see, everything seems to be connected. We have position information for those 4 nodes, and with that we can start making our mover script. So let's go ahead and create a new script, call this one rail mover, and this script is what we're going to be applying to whatever object we want to move, so in our case the camera. So let's go ahead and do that right now. Actually, select your camera, drag and drop your new rail mover script on top of it. Okay, Once this is done, we're going to go ahead and clean our script just a little bit and also define some fields. First one being public rel, and also we're going to declare a public transform, which is going to be the look at object, so whatever object we're currently looking at. And also, just for the purpose of optimization, we're going to declare a private transform, and it's going to be this transform. Let's assign it right now, so private void start this transform is going to equal transform. Okay, good. So now let's take a look at what exactly we need to be doing to calculate the position of our camera. So we need to take the position of the player right now, in this case this capsule, and we need to find which of these four balls, which of these four nodes is the closest one. And say it is this one, and I'm selecting right now. We need to test the position of our player against this segment and also this segment. In case we are closest to the first ball, then we simply need to test it against this segment. Same thing for the last one and this last segment. Okay, so in order to do that, we are going to go back into our Rails script. We're going to create a public vector3, because this is going to be the big function, the final one we're going to be using, public vector3, and we're going to call this project position on rail, and it's going to take in parameter the position of our player or whichever look at object we're looking at. So vector3 position. In there, I will start by declaring a int that I'm going to call closest node index, and for now it's going to be equal to 0, but we're going to create a function that gets the closest node just a little bit later on. Then we said if the closest node is equal to 0, so if it's the first node, we are going to need to project on the first segment if the closest node, so else if closest node index is going to equal node count minus 1, which is the last one, we are going to need to project on the last segment, and say it is a middle node, so else we're going to need to project on the two connected segments, and then we simply return the shortest vector, the shortest segment. Okay, so let's get started and create ourselves the get closest node function first. So let's go below that, say private int get closest node, and of course we're going to take in parameter the position of the player again. So in order to calculate that, we're going to declare ourselves some fields. So say int closest node index, which is going to be what we're going to return at the very end. So let's go here, say return closest node index, and now we need to calculate it. We're also going to need a float that I'm going to call shortest distance to keep track of the distance we are actually calculating right now in our for loop, because we need to iterate through every single of those nodes. And we're going to say for int e or int I is equal to 0 as long as I is smaller than node count, I++ again. So we're going to say float square distance, because we're going to be calculating the square distance to save some memory, is equal to nodes minus the position of the node dot square magnitude. Okay, now let's test this out. So if the shortest distance is equal to 0, which it will be for the first iteration, or the square distance is smaller than the shortest distance, then we're simply going to say shortest distance is equal to the square distance, and also that the closest node index is equal to this one, so is equal to I. and this way we're going to be iterating through all our nodes to get the closest one. So let's go ahead, take this function, replace our int closest node index by this. I can remove the comment now, and we need to feed it the position, don't forget about that. And now what we need to do is code the project on segment function. So let's go ahead and create ourselves another function down here. We're going to call this private vector3 project on segment, and this one is a little bit more heavy, so try to follow. It's going to be a little bit of maths. So we need a start point, so vector3 v1, also a endpoint, so vector3 v2, and also the position we're testing against, so vector3 position. Okay, so now first thing I want to do is create a vector3 vector1 to position is going to equal position minus vector1, and then we also want a direction vector in between our 2 points, so vector3 segment direction is equal v2 minus v1 dot normalize. And the reason we want these, it is because we're going to need them to apply the dot product in order to get the intersection point. So that's a little bit complicated, but just follow with me. So we're going to declare a float. Float is going to be called distance from vector1, and it's going to be equal to vector3 dot dot, and we're going to feed it the direction and also the vector1 to position that we just calculated. So this should give us the distance from the first point to where we should be on the line. If we cast this, if we try to find the intersection point using the dot product. Now let's test something out first. So if the distance from v1 is less than 0, that means we're not on the line. And if that's the case, we're simply going to return the vector1, so the first node or the first point. Now let's check if otherwise it is too far away from the segment. So if distance from v1, and I'm going to say times distance from v1, because if you remember, we're calculating the square root, or actually the square amount of the distance and not the distance itself. So if distance from v1 times distance from v1 is bigger than v2 minus v1 dot square magnitude, that means we are too far away from the segment, so we're beyond it. In that case, we return v2. And in the case that we're actually at the good place, so we're somewhere in the middle of those 2 points, we're going to say vector3, so from v1 is going to equal direction times the distance from v1, and that will give us the exact point from vector1 to the point we want to be. So let's simply say return v1 plus from v1. Okay, so that's a little bit complicated. Let's test it out before we actually implement it into the project position on rail function. So I'm going to change this temporarily, so it's going to be public now, and I'm going to use it in my rail mover script. I'm going to go ahead and create a private void update in here and simply say this transform.position is equal to rail.project on segment, and now we need to give it to fictional points, so new vector3. Actually, I'm going to give it vector3.0, and this is just for testing purposes. And I'm going to give it say vector3.forward times 20, and finally give it the position of the player. Or actually no, we have to give it the position of the player, which we will get using the lookat.position call. Okay, got all called pad return value. Okay, so let's go back here and I'm actually just going to comment out this just for testing purpose. If you're not doing it, you don't have to comment this out. We're going to come back to it in a moment. And now I will go ahead and on my rail mover script, that is on my camera, I'm going to assign the rail as rail and the capsule, which is my player, as the lookout transform. Hit play. And now there should be two fictional points in between vector3.0, which is here, to vector3 times, or vector3 forward times 20, which should be around here. So my camera is following me on the point until it hits 0, and when it does, then it simply returns the end position of my fictional rail. Okay, so the project on segment function is working. Now what we need to do is replace the start point and end point with values we get from these nodes. And we are going to be doing that just here in the project position on rail function. So I'm going to remove this call from my update, and we are going to finish coding this function. So if we are on the first node, we're going to return project, project on segment. So return project on segment, and we're going to feed it the nodes at the index 0 and the node at the index 0 plus 1, or actually just 1. Yeah, that'd be simpler. And you give it the position of the player, of course. Now we do the same thing here if it is the last segment, but instead of 0, we're going to say node counts -1, and the endpoint is going to be node counts -2. And finally, in order to do that here, we need to project it on 2 segments. So let's go ahead and create ourselves the left segment, and it's going to equal project on segment. Actually, let's go ahead and change this to private now that we fixed it. Okay, so project on segment, and we're going to say nodes closest node index, which we calculated earlier, -1, and then nodes dot closest node index, closest node index, and that should be it. Then we send the position as always. Now we do that again, but this time for the right segment, and instead of being closest node index -1, it's simply going to be closest node +1. Now we should have our 2 segments, and for the sake of just visualizing what we just done, I'm going to create some debug. So debug draw line, take the actual position of the player right now, and I'm going to put the left segment as the end vector. Give it a color, so color red, just for fun. Copy paste this, do the same thing, so right segment, and this one is going to be blue. And finally, we need to say if position minus left segment dot square magnitude, so I'm going to put that in parentheses, the square magnitude is smaller or equal to position minus right segment dot square magnitude. Then if the left vector is smaller, we will be returning left segment, else we're simply going to return the right segment. I'm going to remove those comments, and we're going to go in game, see how this works out. Hit play. And we have a little issue because we forgot to actually put something in our update here. So let's go here and say this transform.position is going to equal rail.project position on rail, and we're going to feed it the lookat.position transform dot position. Okay, hit play, and now as you can see it is following the rail, so it's always on the closest point on my network or the rail network. Okay, so now just to make this a little better, what we could be doing is we could actually make this disappear, the transition. We could smooth out this movement, and we could also make sure that the camera is actually looking at us, because if we looked at the game screen right now, we can actually lose the player if we go over here. Right, so let's start by looking at the player. That's the easiest thing to do. So in the update function, we're going to say this transform dot lookat is going to equal lookat dot position. Let's hit play and look at it. And it is now looking exactly at my player, which is great. That's exactly what we want to be doing. Okay, now the next thing we wanted to do is fix this jump. We want to make sure that we have smooth transition. Okay, in order to do that, I will go ahead and create myself two new public fields. So public bool smooth move. In case we don't want the smooth move, we just have to turn this off in the inspector. And then I'm going to say public float move speed, which is going to be equal to 5 for now. And in order to keep the data, we need to create a new vector3 that I'm going to call last position. And this vector3, I will assign it in the start. So last position is going to equal this transform dot position. And now we are simply going to go in our update, say if we're smoothing the move, open the curly brace, else call this other function that we had. In here we need to start by calculating the last position. So last position is equal to vector3.lerp, and we're going to feed itself, so last position, and then feed what we should be at right now. So I'm going to go ahead and take this, copy, paste, and also time.delta time as the moving parameter, so delta time. And I just realized that we don't actually need the move speed, so I'm gonna take it off from there. Okay, also we need to update this position, so this transform.position is going to equal last position. Now let's take a good look at this, and everything should be working exactly the way we want it to be. Yeah, so this is actually quite great, and forget what I said, we actually need that move speed. So public float move speed, I'm gonna put it back there, and I'm gonna multiply the delta time here by move speed so we can get some faster transition. And as you can see, it follows exactly what we want. Now this isn't looking too great because my level and my rail network is not really well placed. I will go ahead and make myself a quick level with a quick rail system, and I'll see you in a moment. Alright, so now let's take a look at this. I've just placed a little rail system a little bit better, and also have a terrain just for that I've just generated. And we will go ahead and move in there, see if it works. And everything seems to be working just fine. It has some nice smoothing as well. And yeah, that's pretty much all we need. So also remember that it doesn't have to be a camera, it could be pretty much anything. It could be some kind of object that follows you in a level and that has to keep a certain path. So just be creative, do whatever you want with that, and we will see each other in the next episode. Bye guys.